7 is the cosine law, and the cosine law, again, we're going to make sure that we know how to label a triangle properly, right? So the vertices are capital A, B, C, right? So A, B, C, we usually use that for vertices, and we consider the opposite side here to be the length A, right? That's the length A. So if this is B, then the opposite side here, you're pointing to the length B. You don't have to call it length B, you can call it AC, but you know that that opposite side is the one we're referring to. And then here, for the C, again, that opposite side would be the lowercase c, which is, you can call it AB, but we know that that's the length we're referring to. So the way that you label a triangle does matter in terms of the formula, right? You can't say, oh, I decided to label it differently. The formula relies on the labeling being the same. Based on the law of the law of cosines that they develop, it's always going to be a squared equals b squared plus c squared, then minus 2bc. So you can see that these two letters match. BC is the BC, and the cos A matches the A here, right? And that's the same for all three formulas. We talked about this before when we did the little review of grade 10, right? The mini review that we did. So we talked about that matching, and it matches for all of them. So B is the B and C is the C, right? There is another version of the formula, and you ask that where it's already isolated for the angle. I don't tend to memorize another variation. This is the cosine law. There's the one where you've already pre-solved it. I don't tend to memorize that, so if you want to memorize that one, you can. Okay, but I tend to just use this, and I use the algebra to solve it. We will not give you any of the formulas on any evaluations, right? So you need to have this, right? And you're not writing it on your person, in your calculator, on a Post-it note, on your desk, nothing, right? So if anything's written anywhere, it's a 0, right? Come in as soon as if you think you're going to forget it, as soon as you get the test, write down the cosine law, right? So that's what we used to do, is that you grab the page and write down whichever formulas you need right at the top of it, so I know why it's written at the top of your page, right? Or on the rough paper, take the rough paper and write down the formulas. Okay, but you're not to have the formulas written anywhere else. Okay, so that's the formula. It's not too bad. I always kind of start it with this. A squared equals b squared plus c squared, right? Then minus, and then bc, it's the same two letters, right? Same two variables, and then cos of a, and it matches. So it's not too bad to memorize. All right, then we have the triangle. So RS is 6, ST is 13, TR is 9. I didn't give you any angles. We're going to solve the triangle to 1 decimal. I always want you to provide a diagram whenever possible so that I can see what you're thinking, right? That way, if you've drawn the diagram wrong, I know where I'm following. I'm like, oh, okay, because your initial diagram was wrong. So here I have just 3 sides, 1 longer, kind of 2 medium, so I can just do any general triangle. 2 medium. I'll actually... I'm going to make this one a little bit shorter just so it doesn't look like it's an isosceles. Okay, so I want 3 sides that are not the same. So this one I'm going to call it 6 because it looks a little bit shorter. So RS, so I'll do R to S. S to T, I'll give it the longer side because it looks a little bit longer. And TR, I'll give it kind of the medium side, 9. Right, so again, you don't have to measure your diagram. You just want it to be something useful. If you make all of your diagrams look exactly the same, and we talked about this last time, making them all look like, what did we call it, equilateral triangles, that's not so useful. Right? And then we talked about what an equilateral. Some people make all of the triangles look exactly the same like this, no matter what I say the side length is, which isn't super useful. So try to make the 13 a little bit longer, just so it kind of makes sense to you when you're looking at it. So like that, labeled all around with the letters and the numbers. I want you to solve the triangle, and we talked about solving. Solving the triangle means that you're finding everything that's missing, right? So everything that's missing, so I'm missing the 3 angles. Now, based on this, we always say SOHCAHTOA is not allowed because there's no 90 degrees. So definitely no SOHCAHTOA, can't even enter your mind. No possibility of SOHCAHTOA. Then the other possibility I usually go through is sine law. If sine law is possible, then that means I'd have an angle and its opposite. I have no angle and its opposite. I have no ratio. So then it has to be cosine law. Cosine law is the one with the 3 sides. Or, and I'll talk about the other scenario as well. Right? So cosine law is usually the 3 sides, or it's the side angle side, which we'll talk about in a minute. So this one here is the 3 sides. You can start with any angle that you want to find. Usually I start with the larger side because if this is obtuse, then I would get the obtuse side. But it doesn't matter until we're using it for the second step, which brings back the ambiguous case again, but we'll get more into that later on. But here I would start with the longer side, right? So start with the longer side. I go 13 squared equals, and I go 6 squared plus 9 squared. So I start with the easy part of the formula. So as I'm doing this with you, we're memorizing the formula as we do it, right? So I know it's 13 squared equals 6 squared plus 9 squared. Then we go minus 2, and it's 6, 9. The same two numbers, and we're doing cos, and it's the angle opposite the 13, so it's cos r. So as I'm doing this, I'm memorizing the formula. I do not need, so this is the first line that I want to see. I do not need you to do this with the letters. So I don't have to see, and I think someone asked that before. I don't have to see r squared equals s squared plus t squared minus r st. I don't need the letters. Most teachers just accept this, right? Because that's showing you've got the formula. It's sometimes harder with the letters because especially if I don't give you the letters, everyone has to name them separate things. It becomes more complicated. So this is beautiful for a first line. Okay, so right there you start. Then when I'm solving for the r, and like I said, some people memorize the other formula where they've already isolated it. So they did this already, so they brought this over, and then they divide it. I just memorize one, and then I bring it over as I need it. Right, so I'm going to go 13 squared minus 6 squared minus 9 squared equals, this part here is still negative 269. If you want, you can calculate this as one number. Right, so I didn't show you that when we were doing the grade 10 review, but if you want, you can do this as one number. Negative 2 times 6 times 9, so negative 108. Negative 108, 2 times 6 is 12 times 9, so negative 108. So if you want, you can do that all together and make it negative 108. Okay, some people like to do that, and it just simplifies their next step a little bit. Okay, so I did that part. That's the purple part here. I was just showing you this. So if you want, you can do that. If not, you can keep it as 2 times 6 times 9. Then I'm going to divide both sides by whatever's over here, so negative 108. That cancels the whole thing away, so it's all gone. Okay? And then on my calculator, I don't need you to write any other steps. So again, in grade 10, grade 10 teachers teach it differently sometimes, depending on who your teacher was. Okay? Some teachers teach it asking you to show more steps than this. I don't need it. I don't want you rounding too many times. So I would do 13 squared minus 6 squared minus 9 squared. So I do that all at once. I press equals. So that means I finished all of the numerator, and I keep it there on my calculator. Then I go divided by, and it's negative 108, like that, and I get negative 0.48, blah, blah, blah. Okay. Then I press second. I'll do it again. So second, so shift, cos, and I get my angle all at once. So without having to round it. So again, let me show that again. 13 squared minus 6 squared minus 9 squared. I press equals to finish the top. I don't need you to copy that down. So just keep it on the calculator. Then I go divided by negative 108. If you didn't divide by negative 108, I can still go divided by bracket negative 2 times 6 times 9. So you can do that, bracket. Like, so if you're like, but what if I don't do negative 108? I put a bracket, I do this. And I put it all in a bracket, equals. So I'll get the same answer, which is negative 0.48, blah, blah, blah. I don't want you writing that number down, right? And I know in grade 10, some teachers said write down that number. I don't want you rounding it twice. So this keeps every decimal. It actually has more decimal in its memory, right? So in its memory, it actually keeps going, right? It's showing you what it has here. Then I go shift cos, and if you press equals, it grabs your last answer. So it's telling you, I grabbed your last answer and I took the inverse of that. So you don't have to press answer and put it there. You can, but also the calculator is programmed to grab your last answer when you press equals. For trig stuff, right? For trig stuff, it always does that. So this is going to be 118. So that means I only had to round one time. It says 1 decimal, so it'll be 118.8 is approximately R. And make sure you have the degree symbol, okay? If you don't have the degrees, okay, I should not have to take off any marks for this, but I will. I don't want to, but I will, Okay, so no missing degrees here. And I only had to round it one time, not 2 or 3 times. Okay, so for the next step, you're allowed to use, so once you have the 118.8, so this is 118.8 degrees, you can use cosine law for the next step. You can use sine law for the next step. I like cosine law. I'm going to use cosine law again for another one, right? I like cosine law. Also, cosine law does not come up with the ambiguous case. And you'll see this when we do word problems, and we talked about the ambiguous case last time. Sine law has the possibility, if you choose two sides that are not containing an angle, you have the possibility of creating an ambiguous case. Cosine law has no ambiguous case. There is one answer. So if I use all 3 sides, I'm only going to get one answer. So I'm going to use cosine law again, and I'm going to do it I'll do it for 9. So I'm going to go 9 squared equals 6 squared plus 13 squared. And then remember, it's minus 2, and it's 6, 13 cos, and opposite 9 is s. I'm going to use cosine law again. I like cosine law. It doesn't create an ambiguous case. It's easy to use. I get one answer. Okay. Practicing, we're going to bring these two over, and I'm going to chunk those together. So this is 9 squared minus 6 squared minus 13 squared equals, and then these 3, right, I'm going to do those 3 together. It's 2 times 6 times 13, 156, so negative 156. And that's cos s. Is that okay? And then I divide both sides, and the rest is on my calculator. Okay, so try that on your calculator. 9 squared minus 6 squared minus 13 squared. I press equals, so I get the top, so I get negative 124. Divided by, oh sorry, my 156 looks messy, 156 divided by negative 156, and I'm getting 0.79. Why am I always getting a decimal? Do you know why you're always getting a decimal there? Yeah. It's a ratio. And remember, the cos ratio, cos of any angle, is so ka, right? So it's adjacent over hypotenuse. What's the longest side of a triangle? Of a right angle triangle. What's the longest side of a right angle triangle? Hypotenuse. So this side will be the longer side. So it'll always be a smaller number divided by a bigger number. Someone asked me, why am I always getting a decimal for that? Because it should be a decimal, because it's the ratio of adjacent to hypotenuse, and the bigger number is on top, always. Right? So it should be a ratio less than 1. If it's not, then you put the hypotenuse on top, which means it's the reciprocal ratio, right? So that means it would be the wrong one. That's why someone asked me before, like, why is it always a decimal? Because of the ratio. Okay, so then you get 0.79, something, something, something. I don't care, I'm not copying it down. I'm going to go shift, where my cos equals, and I got 37 point, okay, with the 5 after, right? So it's going to be 37 point, it's 3.5. So if it's the 5 after, I round it one time, so it'll be 0.4 degrees. Does that make sense? So one time, the 5 after the 3 makes that round up to 4. Okay, and not forgetting, so check, double check, you got your degrees, right? Do not lose any of these marks. And then for the last angle, which am I looking for? T, I'm just going to do 180 minus. So 180 minus 118.8 minus 37.4 degrees. And I'm just going to do a subtraction. And this gets me, I got 23.8 degrees. Okay, and again, try to keep your degrees where the degrees are. Okay, people drop them all over the place, and then you forget to put it down. So just get in the habit of just putting it wherever it belongs. Even in your homework, right? Sometimes you're like, I'll do it on a test, but then muscle memory, you forget to write it. You just automatically, your hand should be degree, degree, degree. Okay. When we're solving, I asked you to put a little therefore statement at the end just so I can find all of your answers at once. So go therefore R equals 118.8, S equals 37.4, and T equals 23.8. Okay, just because there's a lot of calculations around, so a little therefore to sum it up. Only the stuff that was missing. Don't tell me what I gave you, right? Don't tell me side R, S, and T. Okay, next one. Sorry. Any questions with that? Yeah.
Sorry, I'm confused how we got the 37.4.
37.4, the calculation or the setup? Okay. All right, so let's do it together. So 9 squared minus 6 squared minus 13 squared. Press equals. Do you get negative 124? Sorry, there's a glare. Yeah. For the numerator. Okay, then press divided by, and then and then 156 is okay? So, yeah, so divided by negative 156 equals, and you should get 0.79. Okay, now are you in degree mode? Is there a D? Okay, so shift cos. Yep, and then press equals. Okay, good. And we have to check for this test that we're in degree mode, right? Because there's different modes that the calculator can be on. So right at the beginning, be like, check your mode, right? Check your degree mode. Okay, good. So the next one is aircraft control tower T was tracking positions of 2 aircraft at points A and B. At the last check, A is 3.5 kilometers from the tower, B is 7 kilometers from the tower. ATB is 16. I'm going to start with that. I'm going to start with the angle. So whenever I draw my diagram, I kind of start with the angle of diagram, and I'm going to go, okay, so I'm going to do a diagram here, and I'm going to make it 16, so something small. I have no idea where anything is. I might have to extend the lines. So I'm going to go 16. So small angle. So it's ATB. So I'll do A to T to B. I might have to extend it, so I'm just going to do this tentatively here. Wait. At the last check, A is 3.5 from B, and B is 7 from the tower. Oh, I totally drew that backwards, so this A has to be way shorter. So B is 7 from the tower. T is tower, so B needs to be longer. There we go. So B is over here, and that would be 7. And A is 3.5 from the tower, so opposite. So A is here, so A is 3.5. So 3.5. So that should be shorter than this, about half. It doesn't have to be measured, just about half or shorter. So there, A is 3.5 from the tower, B is 7 from the tower. Does that make sense? We have 2, and the person on the tower is here looking at the 2 airplanes. A to T to B is 16, so this angle here, this angle here is 16. Find the distance between the aircraft. So A and B are the aircraft, correct to 1 decimal. So I'm looking for this distance. That's the distance I'm looking for. Right, so draw a diagram. Usually we always ask you to draw a diagram whenever possible. That way we can follow your answer. All right, so always just get in the habit of drawing a diagram. And this is the case where there are 2 cases where cosine law is useful. 3 sides, which I just showed you above. And here, if it was the angle side, side, angle, side, the contained angle in between. Because look, no ratio, right? The sine law is if you have the angle and its opposite side. This does not have the ratio. So cosine law is if you don't have that ratio, you have side, angle, side. Okay, so when I'm finding AB, then I know that that is the side that matches the angle. So this is going to be AB squared equals 3.5 squared plus 7 squared, and the formula goes minus 2, and then the same 2 numbers, 3.5, 7, and cos of the 16. degrees. Again, try to keep your degree here, please. Okay, people start to lose your degree symbols. And again, try to do it for homework because it's muscle memory. You just automatically, I almost can't stop myself from doing it, right? So if you said don't do it, I'm like, oh, but muscle memory, I write it down, right? So these guys match. Remember, that's how the cosine formula works, right? So the AB matches this, so that's why we're using it. And now this one, the variable, the unknown, is here on one side, so we just have to calculate the right side. That's it. So on your calculator, so again, I don't need to see anything other than this step here, right? So show that step there. Yeah.
So I didn't know what you said. You said we could do sine law as well, right?
Not for this, no. There's no sine law possible. Can you close the door? Just so, yeah, it must be distracting you. Right. So no sine law is possible because
Isn't it like a contained angle?
no, but yeah, it's a contained angle, but that's not sine law. Sine law is this case. Sine law is always when, if I have, say, a triangle, and if I have this angle and I have this side. So if I tell you that this is 50 and I tell you that this is 12, I can do it the sine law. Sine law is only when you have the angle in its opposite ratio, because then it gets you 12 sine 50. That's the ratio, right? So that's why. So only when you have a contained angle, and sorry, not contained, it's the angle in its opposite side. All right? So then no sine law, so we're on to this one. Okay. So over here, we're going to do cosine law. All I need is the formula, and then let's just punch the whole thing into your calculator without approximating once, right? And without having to copy out a big long number. So let's do 3.5 squared plus 7 squared minus 2 times 3.5 times 7, or you can do brackets, and then cos 16. I don't think I need to do times cos 16. Let's see if this works. Equals, and I'm getting 14.148. So what happens is that you say, oh, AB is 14. What's wrong? Haven't done the square root yet, right? Because that's AB squared. Now, this is where I say, try to make the diagram something useful. And I'm going to emphasize this because in grade 12, when we do the calculus and vectors, I keep saying the same thing. Your diagram shouldn't always look like, what did I say? The isosceles that. Because you're like, oh, they all look like that. No, because we just said that should be much longer than this. So if you take just a few minutes, not to make it accurate, I don't want you measuring. I don't want you measuring anything, lengths, and just make it something so it's useful. You know that AB cannot be 14. As soon as you put that down, you'd be like, that's ridiculous. That side is definitely not longer than that, not double. So something went wrong. I forgot to press the square root. So when you look at it, you go, huh, that's weird. There's no way that's 14. Does that make sense? So then the diagram is useful. If you draw everything, like I said, like an equal out, then the diagram is useless because it doesn't mean anything. But you look at this and go, no, 14's ridiculously long. Oh, I forgot to press square root. And then if you press equals, it grabs my last answer, 3.7. That's much more reasonable, right? So you know it's a shorter side. It's closer to that. Okay, so then I've got my answer. So then you go, so I don't need to see anything other than this. Then you're going to go AB with the square root. I did it. Is approximately 3 point, it says 1 decimal, 3.8. And then if it is a question with towers and stuff like that, you do a therefore sentence. I want a sentence. So it would be therefore, find the distance between the aircraft is 3.8, and you're going to make sure you add the units. Always do the units, and it's kilometers, right? So make sure you do a sentence. So I just need the formula, your answer, making sure that you did the square root. So that's my brain going square root. People forget that when they're doing the cosine law.